Okay, let's go over this quick check. For number one, we need to graph the solution. So when it says that, it really means what is your shaded area. For the linear inequality shown, you should have had a dashed line with a positive slope, with a positive y-intercept, shaded above, and then pick one point that would be a solution. I picked 0, 4, but someone else tell me a solution they found.
Negative 3, 5.
Negative 3, 5 would also work. If you pick any point on this line that would not work, but any point in the shaded area would. Number 2, you needed to solve that one, get it in slope-intercept form first. So subtract your 6x, divide everything by negative 5. Remember that when you're dividing, your sign needs to change because you're dividing by a negative. Your equation should have been y is less than or equal to 6/5 x minus 2. So negative y-intercept, positive slope. This should have been a solid line, and when you flip the sign, you were now shading below. This one did not ask for a solution point, but what would be one? 4, negative 5 would work. Anything on this line would also work because it's included or it's also equal. Number 3, you needed to check and see, is this point a solution? The easiest way to check that is to put it back in and see, is this a true statement or is it not? So when you put in x and y into your inequality, you get 5 plus 1 is less than 6. So 6 is less than 6, and that is not a true statement, it is false. So this would not be a solution because this statement is false. If it were true, then it would have been a solution. Do you have questions on any of this? So now we're going to take all the knowledge that we've been doing the last couple of days on graphing, and we're going to apply it to the notes we're going to start today on systems of inequalities. So from our last unit, we know systems are more than one. So here we have 2. But when we talk about systems of inequalities, we're not solving 2 of them like compound inequalities. We're graphing 2 of them. So it's like systems of graphing, but it's systems of inequalities. So all of the rules for graphing still applies. All of the rules for graphing linear inequalities still applies. So I think on your notes, some of this is blanked out. So if you want to rewrite this, you can. Or if you know it from the previous notes, that's fine too. But just as a reminder, for inequalities that are less than, this is greater than and less than, strictly greater than, strictly less than, we use the dashed line. For inequality symbols that use the equal to, so greater than or equal to, less than or equal to, we use a solid. If the inequality says y is larger, which means greater than or equal to, we shade above. And if the inequality says y is smaller, which means this is less than and less than or equal to, we shade below. So basically, we're going to take everything we've learned, and now because we have 2 of them, we're going to do this twice. The graphs on the front are a little small. So we're going to jump down to the last example on this page, and then if you want bigger graphs, I have small graph paper that you can read those top 3 on. So make sure that you have these notes out so we can start on this last problem. So just like when graphing inequalities, if they are not in slope-intercept form, we have to get it in slope-intercept form. So this first inequality, we need to convert it. Add 3x to both sides. So we have 5y is less than 3x plus 10. Divide everything by 5. So we have y is less than 3/5 x plus 2. And then graph that one. So this would be at positive 2. Our slope is 3/5, so we're going to go up 3 to the right 5. And down 3 to the left 5. This one would have a dashed line. I'm going to make these actual ones. And this would be shaded below. So because we're going to have to do 2 of these, I would recommend doing one of the following things. Either using 2 different colors, a pen and a pencil and a color pencil, pencil and a highlighter, whatever. Or drawing your shading different. So maybe you draw one shaded with diagonal lines and one shaded with vertical lines or horizontal lines or something like that. Somehow to show that this is one and this is the other. Yes. And then we're going to do the exact same thing, but graph the other one. So this one would have a y-intercept at -5. Slope of -2. We're going to go up 2 to the left one as many times as possible. And down 2 to the right one as many times as possible. This would be a solid line. And this is shaded above this line, so just in case you're not sure where that is, that would be up this way. So when you draw your second shading, you're going to see that some of this overlaps. The part in which they overlap is your actual solution area for the system of inequalities. So when you're looking for answers that work, let's outline this again. They're only going to be in this area right here. Let's make that bigger. So we're only going to focus in that section. Not in just the blue, not in just the purple, but where they're combined. Before we find which points are solutions in this system, do we have any questions, concerns, confusion on how we graph that part? So then again, to see these, the easiest way is to plot them and see do they fall in this area or not. So -2, -2 would. 1, -1 would. 1, 1 would. 2, 5 only falls in just the blue, so that would not work. And 6, 0 does. What if I had something like this on this line? This point 0, -5. Do you think this would be a solution?
Yes, because it's on the solid line.
Okay. So when there's one, that works. We need to make sure this works for both. If it doesn't work for both, then it's not a solution. So let's test that and see. So we're going to put this into this and this, both inequalities. I'm going to rewrite them so I know them. Y is less than 3/5 x plus 2. And y is greater than or equal to -2x minus 1. For the first one, this would be -5 is less than 3/5 x times 0 plus 2. This would become -5 is less than 0 plus 2, or -5 is less than 2. Is that a true statement? -5 is not less than 2?
Oh.
Yes, it is a true statement.
How would -2 -2?
Oh, because I graphed that incorrectly. I definitely put 2. No, it should be. It should fall directly in it. But I can look back at it in 1 minute. And then the other one, -5 is less than or equal to -2 times 0 minus 5. So this would be 0 minus 5, -5 is greater than or equal to -5. Is this a true statement? Yes. So because this works for both, we can say that this is a solution. But always check it, especially if it falls on a line, because it could not work for both. Especially if it falls on a dotted line, check it. But when it falls on a solid, it could work for the solid but not the dash. I think is what I meant to say. So just always check it. If you have two solid lines, you really have nothing to worry about. It's going to be a solution. But if at least one of them is dashed, check it. Do you have any questions on this part? Then very next page is more of like what we did yesterday, writing the inequalities and then stating a solution. We're going to come back to that. We're going to jump to the calculator page, and everyone needs to go grab a calculator. So yours might be right. I'll have to draft it again on like paper.
So I checked in Desmond's and it says it wasn't.
Okay. So mine, I probably just missed something. Before we do anything, reset your calculator. Second plus 712. So this is really just to help you kind of see it on your calculator as a checking method. Did I graph this correctly? Is it shaded in the right area? Things like that. So after we do this, if you feel like you're good, you don't need this, that's fine. If you would like to use this as a checking method, that's also fine. So on your calculator, you can find the APPS button, APPS, next to math. I have way more apps than you guys do. You should really only have like 4. You're going to find that one that says Inequalities, but with a Z. If you have more than 4 and you don't see it, you can hit alpha I, and then it'll show up. But once you hit Inequalities, hit Enter. This should pop up. After you're in this, go back into Y equals. And let me do this. So I'm going to go back and forth between these two so you see where it is. But at the bottom of your screen, if you go over to where the equals is and it's highlighted, you should see these options pop up at the bottom. That's to help you change the inequality. So whichever inequality you need, you would press the buttons at the top, the Y equals, window, zoom, trace, graph. It really doesn't matter which ones we use. You can use the ones that are in the example, the 3x plus 2 and the -1/2 x minus 4, just so we can see it. So I'm going to put those two in, and I need the first one needs to be less than, and the second one needs to be greater than or equal to. So if the first one is less than, I'm going to hit window. Oops, except I need to actually be on the thing. Maybe not this window, maybe it's second window? No. Alpha window, there we go. If I read it, I would have got that. Alpha and then window, or alpha and then whatever symbol you need. It will change this to an inequality. It will also change this part to show you that it's going to be shading below and that it's a dashed line. And then you can put in your inequality after that. So 3x plus 2. And then I can go to the next one. And I want to change this to a greater than or equal to. So that would be my graph. So if I hit alpha and then graph, it would change it to a greater than or equal to. It will also show me that this is going to shade above and the line is solid. The only thing that's not real nice about this is that you can't put fractions in here. So you have to use parentheses. So parentheses, negative 1/2 x minus 4. After you have both of those in, you can hit graph. Now, mine will be in color, but yours will be in black and white. But you'll be able to see the different lines going different directions, so you'll see where they overlap. Mine will basically do the same thing, but in color. So I can see this section where they overlap is just this area right here. There is another thing that I don't think I put on this. Okay. If you hit alpha and where it says shades, so y1 or y equals alpha y equals, you should get a menu that looks like this. Original shade would be like what you see now, all three, both, sorry. The one, the second, and where they overlap. If you want to see just, I'm sorry, the union would be everything. So union doesn't really help us much. The intersection would be the one we actually want. So if I go back to alpha y equals, what it does is it shades where one is supposed to be, and then it takes the other part off, and it just shows you where they would intersect, or like where your solution set is. So that would be a really good check method. Once you get into this, go to shades, do intersection, go look for this part. Does my graph match this? If it does, I did that correctly. If it doesn't, something's wrong. Do you have any questions on the calculator part of that? I believe if you want to use fractions again, you have to turn it off. So go back into apps, go back into Unequals, and hit enter again, and quit it. And then you'll be able to use fractions and use your calculator like normal. Yes. Yeah. Desmos is a lot easier, so if you're at home practicing, use Desmos to check yourself since you don't have these calculators. But with Desmos, you really just type in the inequalities, it graphs it for you. You can easily see, it will make it a dashed or solid line and shade it for you. So we're going to do one more example really fast and then be done for today. All of these things is a minute. Find this page. The answer to this is overlapping region. And we're just going to do number 1 on there. So with number 1, we need to solve both of these. I would, if you're going to use 2 different colors, maybe signify, okay, the first one is going to be this color, the second one's going to be this color, or whatever. So we would need to subtract x on both sides to get y is greater than negative x minus 1. And we can graph that. Start at negative 1. Your slope is negative, so go up 1, left 1 as many times as possible. Make smaller points. And then down 1, right 1 as many times as possible. Yes. As soon as he gets that. For this one, because it's a dashed line and these are already so close together, just draw arrows at the end. This would be shaded above. So I'm going to do this and draw lines that go this way. You can shade it or do what I'm doing, shade it more. And then go back and do the other one. So subtract x on both sides for that one. But for that one, we need to divide everything by negative 1. So then our sign is going to change direction because we're dividing by a negative. Our y-intercept is now going to be at negative 5. Our slope is positive, so it should be going this way. Up 1, right 1 as many times as possible. And then down 1, left 1 as many times as possible. Again, this is a dashed line. They're too close together, so just draw arrows at the end. And this is shaded below. So this would have lines that look like this. I purposely avoided my dots, but that would be included as well. So at end, if you wanted to like finalize, this is my shaded area, my solution. You could like highlight back over this part or outline that part. Is not necessary. But if you want to make sure, you could do that. Make sure I know that that's your solution area. You could do that. So we are going to stop there for today. Tomorrow we'll do some more problems and then go back and touch on that page where we have to write the inequality. I need to add this to the board. But you do have, in addition to the 3 graphing inequality Khan Academies that are due on Friday, you have 1 system of inequalities Khan Academy as well due on Friday, so that's 4 total due on Friday. And then the 1 system Khan Academy, Delta Math, that will be due on Thursday. So for the remainder of class, you have time to keep practicing, but that is all we are doing for today.